Welcome to Electrical Circuit Analysis. Throughout this tutorial, I'd request you to keep pen and paper with you and solve the problems as we go along so that we can identify our knowledge gap and also consolidate what we just learned. If a circuit has two or more independent sources, one way to determine the value of a specific variable, that is voltage or current, is to determine the contribution of each independent sources to the variable and add them up. This approach is known as the superposition principle. The principle of superposition helps us to analyze a linear circuit with more than one independent source by calculating the contribution of each independent source separately. Here is an outline of the steps of applying superposition principle for circuit analysis. First, we turn off all independent sources in the circuit except one. And by turning off independent sources, I mean replacing each voltage source with a short circuit and replacing each current source with an open circuit. The dependent sources are left untouched because they're controlled by circuit variables. If we turn off a dependent source by force, we're basically opening some of the elements of the circuit. We're basically changing the entire circuit, or the construction of the circuit basically. Next, we compute the desired parameter, that is voltage or current, that we need to compute. And then we follow the above steps for all other independent sources and compute our desired parameter each time. Lastly, we find the total contribution by algebraically adding all the contributions due to the independent sources. Now, if you are confused like this panda here, we're going to see an example to see how this really works. So let's say we have to compute this voltage V here across the 4-ohm resistor using superposition. So to apply superposition, we first look into the circuit and see how many independent sources there are. There are basically two independent sources, this one and this one. So first we keep one of the independent sources, let's say this one, on, and all other independent sources off. We only have one other independent source. So if we do that, we get the circuit in figure A here. So here 6-volt source is active and the current source is turned off, and by turned off I mean it's replaced with an open circuit. And then we compute the exact same parameter, that is the voltage across the 4-ohm resistor. For convenience, it is always better to use a different variable name. For instance, in this circuit I've used V1, in the next circuit I used V2. This is because as we keep analyzing the circuits on each step of superposition, we get totally different circuits, and it's always customary to use different variable names so that these variables don't get mixed up with one another. Okay, you can compute V1 using simple voltage divider here. So in the next step, what we do is that we keep the 3 ampere current source on and all other independent sources off. We only have one other independent source, this 6-volt voltage source. So in this figure B, we've replaced that with a short circuit. Now again, we compute the same voltage, the voltage V2 across the 4-ohm resistor. Now we can apply simple current divider rule to get the current I3 here, and then V2 becomes 4I3. So the last step is to just sum V1 obtained from figure A and V2 obtained from figure B to obtain the overall voltage, which is 10 volt here. And this 10 volt here is basically the voltage across the 4-ohm resistor when both of the independent sources are active. That is in the original circuit. So the contributions, what we did here is that in figure A we computed the contribution of 6-volt voltage source, in figure B we computed the contribution of the 3 ampere current source, and we just summed them to obtain the contribution, or to obtain the voltage when both of the independent sources are active at the same time. Now, if the circuit has three independent sources, we may have to analyze three simpler circuits, each providing the contribution due to the respective individual independent source. That's the advantage of superposition principle. However, analyzing a circuit using superposition has one major disadvantage as well. So we have to analyze, if you have n number of independent sources, you have to analyze n number of circuits. In most of the cases, it involves more work than a nodal analysis or mesh analysis, for instance. And I'd like to stress an important point here. Superposition is based on linearity, so we cannot use it to compute a variable that has non-linear relationship with voltage and current. For instance, power. We know P is equals to I square R, so power and current has a non-linear relationship. Similarly, power and voltage also has a non-linear relationship. So if you were to compute the power across the 4 ohm resistor in the previous example, we couldn't have computed the contribution of the voltage source and then computed the contribution of the current source and then add the power obtained from the two sources. That would be wrong. What instead we need to do for power is that we just compute the current or voltage across the 4 ohm resistor, and then we just use the formula for power, P equals to V squared by R, or P equals to I squared R. So the bottom line is that since superposition is based on linearity, we can only use to compute the voltage and current of a circuit element and not power, because power is non-linearly related to voltage and current. So here is another example. I'd request you to pause this video and try to solve the problem yourselves, and then we'll try to match our answers. So please pause this video. So in this circuit we see that we have three independent sources. So there's 24 volt voltage source here, there's 12 volt voltage source here, and 3 ampere current source here. So we basically have to analyze three circuits. So at first we basically keep the 12 volt voltage source active and turn off the rest of the independent sources, this one and this one. And by turning off, I mean replacing each voltage source with a short circuit and replacing its current source with an open circuit. When we do that, we get a much simpler circuit right here, where we have this 4 ohm and 8 ohm in series. If we combine them, that 12 ohm resistor and 4 ohm resistor will be in parallel, so we can just apply simple voltage divider, or we can simply apply Ohm's law, to compute I1 in this circuit, and I1 here is 2 ampere. In the next step, what we do is that we keep the 24 volt voltage source on, and the rest of the independent sources, this one and this one, off. Again, I've replaced this 12 volt voltage source with a short circuit, and I've replaced this 3 ampere current source with an open circuit. And then we can apply current divider or mesh analysis to compute the current that goes through the 3 ohm resistor, and that's -1 ampere. And in the final step, we keep the 3 ampere current source on and the rest of the independent sources off. So we've replaced this 24 volt voltage source here with a short circuit, and this 12 volt voltage source here with another short circuit. In this circuit, again, we can use current divider or even mesh analysis or nodal analysis to determine the current to the 3 ohm resistor, I3. So I3 here is 1 ampere. So the current in the original circuit, that is when all 3 independent sources are active, is the sum of the currents that were computed in each step, that is I1 plus I2 plus I3, which is 2 ampere. Okay, let's look at another example. So compute I0 using superposition. I'd request you to pause this video and try this problem yourself. So please pause this video and then we'll match our answers. Okay, so at first we keep the 4 ampere current source active and then compute the current through the 5 ohm resistor. And in the second step we compute again the current through the 5 ohm resistor, but we have replaced the current source with an open circuit and we turned on the voltage source. So this is the overall current. So hopefully you have an idea about superposition principle. Thank you for your time.